everyone. So we're starting chapter 5 today, and actually section 5.1 is more like a review section because this is something you should have done in your previous courses. But we're going to go over it just quickly just to make sure that everybody is on the same page and you are familiar with how to solve systems of linear equations. So just keep in mind we are talking about linear equations in two variables here. So they will have the form of ax plus by equals c. Now, of course, you could write this. This is what we call as a standard form, but you could write it in the form of y equals mx plus b, which is the slope-intercept form, or you can leave it in the standard form. So here we are saying as long as you have a collection of two or more equations, we call it a system of equations. And when we are talking about the solution set, for a system of equation which has two linear equations and two variables as part of it, we will say the solution set is going to be a set of all ordered pairs that satisfy both of your equations. So the solution set that we find for the system of equation, like it says here, has to satisfy both the equations. If you have three equations, then of course it has to satisfy all three of those equations. So the first method we're looking at is the graphing method. So you can use whatever techniques you want to use for graphing. Since these equations are given to us in the y equals mx plus b form, or the slope-intercept form, we can use the slope and the y-intercept to graph these. So let's take a look at our first example over here. So for y equals x minus 2, the minus 2 gives us our y-intercept. So y-intercept is going to be at 0, negative 2. And x has a coefficient of 1. So that basically tells us we have a slope of 1 over 1. So basically you can go up 1 and right 1 since it's a positive slope. And then for the second equation, we have y equals negative x plus 4. So again, the plus 4 will give you the y-intercept, which will be 0, positive 4. And since this guy is a negative 1, that means we have a slope of negative 1 over 1. And of course, with negative slope, you can go down and go right, or you can go up and you can go left. So let's take a look at both of these graphs over here. So let's start with the first one. Y equals x minus 2. So we start at negative 2. And then with the slope of positive 1, we go up 1, right 1, we go up 1, right 1. So let's see if we can try and get a nice straight line through these points. And this will be for the line y equals x minus 2. Now let's see what the graph for y equals negative x plus 4 will look like. So that's going to be positive 4. And then since this is a negative slope, I'm going to go down, go right 1, go down, go right 1. So I'll keep doing this till I actually get to my x-axis here. So I will have some good points to draw my line through, and then of course try to draw straight line. Again, if you guys use a straight edge, it will be better, so you will get nice good lines over here. So this is my line for y equals negative x plus 4. Now as you can see, both of these lines are intersecting at one point, and my points are a little off, but this should actually meet at the ordered pair. It looks like positive 3 and positive 1. Now, you know, graphing is okay, but it's always a good idea to check your answers. So let's check and see if this will be the solution set, or will this be a point on both our lines. So we just want to make sure this is going to be part of our solution set. So let's start with the first equation. And we are checking for the ordered pair, positive 3 and positive 1. So y is 1, x is 3. And when we do 3 minus 2, we get 1. So if you're getting a true statement, then we know it's a point on the first line. In that same way, let's check it for our second line. So again, y is 1, x is 3, and negative 3 plus 4 will also give us 1. So we got another true statement. So again, we know that this point 3 comma 1 is going to be a point on both lines. So then we can say the solution set for this system of equations is going to be the ordered pair 3 comma 1. Okay, so this was example 1. Now we have a second example over here. 3y plus 2x equals 6, y equals negative 2/3 x minus 1. So again, you can rewrite the first equation in y equals mx plus b form, or you can always find a table and find x and y coordinates to find a couple points for that line, and you can graph that also. So let's go ahead and take a look at equation example 2 over here. So I am actually going to take my first equation and get get y by itself. So put it in the y equals mx plus b form. I will start by moving that 2x to the other side, and then we will go ahead and divide everything by 3, get y by itself, and we end up getting negative 2/3 x plus 3 goes into 6 2 times, and then our second equation is y equals minus 2/3 x minus 1. So of course you can see our y-intercept is going to be 0, negative 1. Our slope is negative 2/3 here. The y-intercept is 0, positive 2, and again slope is negative 2/3. Okay, so let's graph that first line. We're starting at 0, positive 2, and slope is negative 2/3, so you can go down 2 and right 3. So using these 2 points, nope. Okay, there we go. Something like that. We will have, this is the first line, so this is 3y plus 2x equals 6. Now for our second one, our y-intercept is at 0, negative 1, and we are going down by 2 and going right by 3, or you can go up by 2 and go left 3. So let's see what this line will come out looking like. Okay, so this is our line for the second graph, which is y equals minus 2/3 x minus 1. So I know my lines are not very straight, but basically what happens here is both of these lines are going to be parallel lines, and since they are parallel lines, that means they will never intersect each other, right? Because they're kind of like our train tracks. So they'll never intersect each other, they'll never touch each other. So since they are parallel lines, that means we will have no solution. Okay, now the reason we know they were going to be parallel lines, you can actually find that out by just looking at the equations. So you will notice both of our lines had a slope of negative 2/3. So they had the same slope, but they had different y-intercepts. So that actually tells you that these are going to be parallel lines because they have the same slope, but they have different y-intercepts. Now equations that are of this variety, where basically the two lines end up being parallel lines and you get no solution, we call those systems as inconsistent systems. And then I should have mentioned this on our example 1. where your graph intersects at one point, those equations are called independent equations. I guess I'm write that here. So these are independent equations. For parallel lines, you call them inconsistent, and of course you end up getting no solution as your answer. Now for example 3, again we're given y equals 1/2 x minus 3 and 2x minus 4y equals 12. So let's see what these graphs come out to be. Okay, so let's go ahead and rewrite that second equation in y equals mx plus b format also. So let's start by subtracting the 2x first. We are left with negative 4y equals minus 2x plus 12, and then we'll divide everything by minus 4. You get y equals negative 2 and negative 4. The two negatives will become positive, and then 2 goes into 4 2 times, so you can reduce that fraction to 1/2 x, and then positive 12 divided by negative 4 will give you negative 3, because 4 goes into 12 3 times. So you should notice that we actually ended up with the same equation. I have my y-intercept on that first one as 0, negative 3. Slope is 1/2, and you'll notice the same thing here. Y-intercept is at 0, negative 3, and slope is 1/2. So since they are essentially the same equation, we should expect to see the same line for both of them, right? So let's graph this. We're starting at 0, negative 3, and then our slope is positive 1/2, so go up 1, right 2. Oops. Okay, there we go up 1, right 2, go up 1, right 2. So our graph will look something like this, and this is going to be for our first line, y equals 1/2 x minus 3. Now if you were to graph the second line, you would still start at 0, negative 3, and we would go up 1, right 2, go up 1, right 2, go up 1, right 2, and you would essentially, like I said, come out with the same exact line, because they are basically the same equation. And the one in green, you can write that as 2x minus 4y equals 12. So they are the exact same line. Okay. Some textbooks also like to call these as overlapping lines. So either you can think of them as being the same lines or overlapping lines, it doesn't matter. But you know what happens is, since they are overlapping lines, which means basically both lines are going to be intersecting each other at infinite number of points, because all the points on these lines are going to be common for both equations, right? So for equations like these where you end up getting the same lines, we will say you have infinitely many solutions, because all the points on the lines are going to be solutions for both equations. So we will say infinitely many solutions, and these type of equations are what we call as being dependent equations. And sometimes when they want you to write the solution set, they will actually have you write this in the set builder notation, where you can say the ordered pair x and y is going to come from one of these equations, and it doesn't matter which equation you write down as long as you write down one of them. So I guess I'm going to write it as 2x minus 4y equals 12. So we are saying the solution for our set for this system of equations is coming from this equation, and it's going to be all the ordered pairs. So sometimes you will see these solutions being written in the set builder notation. Okay, so this is how the graphing method works. So you can see we can potentially have three types of answers that show up. where you can have exactly one solution, and it will be that ordered pair where the two lines would intersect. So we say exactly one solution, our equations are independent, and we say the system is a consistent system. And in this case, you would actually have your slopes being different for both the lines. So you would have different slopes on your lines. When you have the same line, same line or overlapping lines, we would say you have infinitely many solutions. Our equations are dependent and we still have a consistent system, and in this case your lines would have the same slope and the same y-intercept. Okay? For systems that end up giving us parallel lines, of course there's no solution because our lines will not touch or intersect one another. In this case we say our system is inconsistent, and in this case you would have the lines that have the same slope but they would have different y-intercepts. So this is kind of how the graphing method works, but you know, the graphing method is not always the most convenient of them, because what if the point where the two lines are intersecting, like we see in this first case over here, what if those lines that they are intersecting are not integers? What if they are intersecting at decimals or some fractions? It would be really hard to just look at your to look at your graph and say what your point of intersection is going to be. So we don't normally like using the graphing method. So we will look at two different methods for that, and that's going to be the substitution method, and later on we'll look at the addition method. So again, you should be familiar with the substitution method, but let's go ahead and take a look at how we can solve this. So let's go on to example 4 over here, and we are given x plus y equals 1, 2x minus 3y equals 8. So in the substitution method, it literally means you are taking one equation and you are going to substitute it inside the other one. So the first thing we're actually going to do is take our equation 1 over here and rewrite it either by getting x by itself or y by itself, and it really doesn't matter which one. So how about we get y by itself and move x to the other side. So we'll go ahead and subtract that x, and you end up getting y equals 1 minus x. So we're just rewriting equation 1. And the reason why we picked the first equation was because you will see both our x and y coordinates are number 1, right? Whereas in my second equation, I have a 2 on the coordinate for the x term, and I have a negative 3 on the coordinate for the y term. So usually when you are doing substitution, you want to select the variable whose, not coordinate, your coefficient is going to be the number 1 or negative 1. But if your coefficients on the x and y terms are going to be anything larger than the number 1, then you don't want to use those variables. Okay? So let's call this guy equation 3. This one here is our equation 2, and this one originally you can call it as equation 1. So what we are going to do is we are going to substitute equation 3 into equation 2. So that means, and since this is y equals 1 minus x, that means we are substituting where we have the y variable in our second equation. We are going to substitute it by using this substitution here, where we are defining y as equal to 1 minus x. So instead of y, we are going to write 1 minus x here. So you're basically taking this value of 1 minus x and you are replacing this variable y with it. So that's kind of how the substitution method works, okay? Alright, now, once you make that substitution happen, then of course the next thing we will need to do is take this, and since there's a negative in front of the 3, we're going to take this negative 3 and distribute it inside our parentheses. So that 2x will stay as it is, and then negative 3 times 1 is negative 3. Negative 3 times negative x, so negative times negative will become positive, and of course 3 times x is 3x equals 8. Now our goal is to find the value. We're not using the graphing method, we need to figure out what the x and y values are if our graph is intersecting at one point. So you want to get x by itself. So let's start by moving this 3 to the other side. And then of course we can go ahead and combine 2x with 3x. So 2x plus 3x of course will give us 5x over here. 8 plus 3 will of course give us 11 over here. And then to get x by itself, divide both sides by 5. And we will end up getting x equals 11 over 5. So think about an example like this. If you're getting 11 over 5, where the two lines are going to be intersecting, then that's not a point you could have easily identified from your graph, right? Because if we tried graphing it, there's no way we could have known where the 2 points are intersecting, and that's why we don't like the graphing method. So now that we have found our x value, we can now go ahead and find the y value. So now, let's go ahead and find y. So you can use any one of the equations, but I think I'm actually going to use my first equation, and usually it's always a good idea to go back to your original equations. So we'll substitute for x as 11 over 5 and then try and find y. So I'll need to subtract 11 over 5 from both sides, and we will end up getting y equals 1 minus 11/5. Now of course we'll need to find a common denominator, so multiply this by 5 and you will end up getting 5 over 5 minus 11 over 5, which will of course end up giving us 5 minus 11 on the numerator will give us negative 6 over 5. So we now have our x coordinate and we have our y coordinate. So that's telling us that we have a consistent system with independent equations, and we have exactly one solution. So our solution set is going to be the ordered pair, where our x is 11 over 5, y is negative 6 over 5. Okay, so this is how we go about working through our substitution method. And you know, the moment you got an answer for x, you should have known that this is going to be a system where the two lines are intersecting. So we're going to have exactly one solution, and then of course we went ahead and found our y. And so we know when the two lines intersect, this is the point they're going to be intersecting at. Now let's look at our next example over here. So we are given y minus 3x equals 5, and then 3 times the parentheses x plus 1 equals y minus 2. So in this case, you can simplify that second equation if you like, or if you want to leave it like that and just go forward and solve it, you can do it that way also, because eventually you are going to have to simplify it, so it really doesn't matter. So let's take a look at this example over here. So again, remember, as I said, you want to find the variable which has a coefficient of 1 when you're trying to make the substitution. So in this case, I am also going to go ahead and rewrite my equation 1 and get y by itself. So you have y minus 3x equals 5. If we just move that 3x to the other side, we can get the y by itself, and that can work for our substitution. So again, you would be left with y equals 3x plus 5, and let's call this equation 3. This guy, of course, will be equation 2. So again, we are going to be substituting equation 3 into equation 2. So my equation 2 is 3 times x plus 1 equals, instead of y, minus 2. For the y, I'm going to substitute it with 3x plus 5. So again, we're taking this 3x plus 5 and we're going to substitute it for y in our second equation. Okay, so now let's go ahead and simplify this. So you want to start by taking that 3, distributing it inside the parentheses, which will end up giving us 3 times x is 3x plus 3 times 1 is 3. And then since there's no number in front of our parentheses, we can actually just go ahead and write this as 3x plus 5 and then the minus 2. So if we try to get our 3x on the same side, we can go ahead and subtract 3x, subtract 3x. So they will actually cancel out up, and they actually cancel out on the right also. You get 3x minus 3x. If you go ahead and combine these two terms, you will end up getting positive 3. Sorry about that. Positive 3 equals 5 minus 2 will also give us 3. So even though our x canceled out, you will notice we are still getting a true statement. So since we were not able to get x by itself and our x canceled out, that tells us that these two equations are not intersecting at one point. And the true statement actually tells us that we have the same lines or overlapping, which means both these equations are going to have the same slope and the same y-intercept. So they are going to be same lines, or like I said, overlapping lines. And this means we have a consistent system. We have dependent equations, and that also means we have infinitely many solutions. So remember, when you're writing your solution set, we write it with the set builder notation. So our solution set will be x comma y, and then use any one of these lines from your original equation. So how about we use that first one, y minus 3x equals 5. So whatever is the solution of this equation is going to be the solution for our entire system. Okay. So this is what it would look like when you end up getting the same lines. Your x variable or y, whichever one you had substituted for, will cancel out and you should get a true statement. When you get a true statement, that's how you know you have the same lines. Okay? Alrighty, now let's take a look at example 6 over here. So we are given y equals 3x plus 1, y equals 3x minus 7. Okay, so y equals 3x plus 1 and y equals 3x minus 7. You should notice that both our lines have the same slope but different y-intercepts. Okay, same slope and different y-intercepts. So that basically tells us that we will have parallel lines. And if we have parallel lines, then we have no solution. So let me just show you what it looks like when you use the substitution method. So since our equations are already solved for y equals, we don't need to rewrite these. So this will be our equation 1. And this will be our equation 2. So we can just go ahead and substitute equation 1 into equation 2. 2. Okay, so we are going to be substituting 3x plus 1 from equation 1 into the y for our equation 2. So we'll go ahead and rewrite this as 3x plus 1. This is where we're replacing the y with the 3x plus 1, and this will equal 3x minus 7. So basically you're setting both equations equal to each other. So let's go ahead and get our x terms on the same side. So let's go ahead and subtract 3x over here. So this will cancel out, and actually it will also cancel out on the right hand side and leave us behind with 1 equals negative 7. Now, of course, we know 1 does not equal negative 7, so this is a false statement. And of course, we expected this to happen because, like I said, we knew these were going to be parallel lines. So as you can see, we were trying to get x by itself, but the x canceled out, and you ended up getting a false statement. So this only happens when we have parallel lines. So this means we have an inconsistent system. And of course, since they are parallel lines, we know there is no solution. Okay. Alrighty, so this is what it would look like when we are using the substitution method. Our x cancels out, we get a false statement, so we know we have parallel lines and inconsistent system. Now the last method I want to talk about is the addition system, and this one actually means you add the two equations in such a way that either the x or the y variable will cancel out. And so let's take a look at how this method would work. Now some textbooks also call this the elimination method. So either the addition method or the elimination method, okay? And like I said, the idea is by adding the two equations together, we want to try and see if one of the variables will cancel out. So that may involve maybe multiplying your equation by a certain number so that we can cancel out either the x or the y variable. So let's take a look at this first example here, number 7. We are given x minus y equals 5 and 3x plus 2y equals 10. So if you just look at this example as it is, of course you will notice that if I just add my two equations together, neither x nor y will cancel out. So we definitely need to think about which variable we can cancel out and how we can cancel it. So the idea is if I need my variables to cancel out, then they have to have opposite coefficients, which means if this guy, my x on the second equation is positive 3x, then on the first equation, the coefficient on x should be negative 3x. Or if the y on the second equation is positive 2y, then the y on the first equation needs to be negative 2y. So since you will notice that my y variables already have the opposite signs, I have minus y on the first equation and I have plus 2y on the second equation. So I'm actually going to eliminate my y variable. And to eliminate the y variable, we are going to need to multiply our first equation by number 2. And the reason we need to multiply the first equation by 2 is so that we can get negative 2y for the y term, and then with this positive 2y, they will cancel each other out. So we're trying to basically create a negative 2y on that first equation. So of course this means you're going to distribute that 2 inside each term of the first equation. So of course remember, this is equation 1, this is what I'm calling equation 1, and this guy of course will be equation 2. So when I multiply equation 1 by 2, I end up getting 2x minus 2y equals 10. Second equation, we're keeping it the same. We're not making any changes, so that will be 3x plus 2y equals 10. And now we're going to go ahead and add both of these equations. Okay, so here you will see that our negative 2y and positive 2y will cancel out. And then 3x plus 2x, of course, will give us 5x on this side, and then 10 plus 10 will give us 20 on the other side. Now, to get x by itself, we'll need to divide both sides by 5, and we will end up getting x equals 5, of course, goes into 24 times, so you get x equals 4. And the moment you get x equals 4, you know that these are going to be two intersecting lines. So once you have found the x, then we can go back and find y. So remember, to find y, go back to one of the original equations, plug your x in and find y. So I'm going to use my first equation, which was x minus y equals 5. X is 4. Okay, so let's go ahead and move that 4 to the right hand side. We are left behind with negative y equals 5 minus 4, of course, will be 1. You need to move that negative to the other side. We need y by itself, so either multiply or divide by negative 1, so that cancels out the negative, and you of course end up getting y equals negative 1. So you're basically looking at the ordered pair 4 comma negative 1, but remember, we need to check our solution and make sure this will work for both of the original equations, right? So we'll go ahead and substitute that and make sure we're getting a true statement for both of these. So for equation 1, x is 4, y is negative 1, so two negatives make a positive. So you end up getting 4 plus 1, and 4 plus 1, of course, is 5. We are getting a true statement, so we know it worked for the first equation. Now let's do a quick check on the second equation. So that was 3x plus 2y equals 10, so that's 3 times 4 plus 2 times negative 1, and let's see, 3 times 4 will of course be 12, and then positive 2 times negative 1 will end up giving us negative 2. 12 minus 2, of course, is 10, so you're getting a true statement on the second equation also. So that tells us 4 and negative 1 is going to be a point on both lines, and that's where our two lines are going to be intersecting each other. So again, we know this is a consistent system. We have independent equations, and our solution set is going to be where the two lines meet. So that's the ordered pair 4, negative 1. Okay. And there we go. So 4, negative 1 is going to be our solution set. So basically, that's the procedure for the addition method or the elimination method. Find a way to add the two equations in such a way that one of the variables will cancel out. Okay, now let's go ahead and take a look at our second example over here. X minus y equals 7 and y minus x equals 5. So this is number 8. So of course you can see your second equation is written as y minus x. So we can go ahead and rewrite that, and I'm going to bring the negative x in the front and bring the positive y as my second variable equals 5, and we'll keep the first equation as it is. So this is our equation 1 and this is our equation 2. Okay, so you should notice here that I have a positive x on my first equation, a negative x on my second equation, negative y on the first equation, and a positive y on the second equation. So if I were just to go ahead and add equations 1 and 2, let's see what happens. So we've got, okay, so you will see I don't need to multiply either of the equations by any number, because when I add these two equations, I already have opposite numbers on my x coordinates, or for that matter even on my y coordinates. So when I add positive x with negative x, they will go ahead and cancel each other out, and same thing will happen actually on the y terms also. The negative y will cancel out the positive y. So since both my x and y variables canceled out, I will get a 0 on the left hand side. And when I add 7 and 5, I will of course end up getting 12. Now as you can see, both our x and y variables canceled out. I have 0 equals 12, which is obviously not true. So since you are getting a false statement here, it's going to mean the same thing as we had seen with the substitution method. Anytime you get a false statement like this, that means we are again looking at parallel lines. We have an inconsistent system, and this of course means we have no solution to this system of equations. Okay, so this will happen when you are using the addition method. Both your x and y variables should cancel out and you should end up getting a false statement. Okay, so this was our example number 8. Now let's take a look at this guy over here, number 9. We have 0.05x plus 0.1y equals 0.6. And the second equation is x plus 2y equals 12. So let's go ahead and take a look at this guy. So as you can see, since we have decimals on that first equation, our first step should be to get rid of the decimals. So on my x coefficient, I have 2 decimals. For the y coefficient, there's 1, and my constant term is also a 1 decimal place. So since I have 2 decimal places on my x coefficient, you actually want to go ahead and multiply this first equation by 100 so that we can get rid of those 2 decimal places. So this will end up giving us 5x plus, this will end up giving us 10y, and of course 0.6 multiplied by 100 will end up giving us 60. Okay, so again, we're multiplying it by 100 to get rid of our 2 decimal places. So once you go ahead and multiply that, you will end up getting 5x plus 10y equals 60 for the first equation. And then of course our equation 2 is x plus 2y equals 12. Now in this case, and let's go ahead and write this guy down here so both of they are together. Both our equations are together. So to be able to eliminate either the x or the y variable, we need to have opposite coefficients. So on my first equation, I have 5x. So how about we have a negative 5x for our second equation? So to make this coefficient on my second equation for the x to be negative 5, we need to multiply the entire second equation by negative 5. So we'll go ahead and distribute that inside and multiply each term of our second equation by negative 5. Okay, so we have 5x plus 10y equals 60 from the first equation that we rewrote. And then multiplying the second equation, we get negative 5x, negative 2 times 5, of course, will give you 10y. And then negative 5 times 12 will end up giving us negative 60. Now when we add these two equations, positive 5x, negative 5x cancel each other out. Positive 10y, negative 10y will also cancel each other out. And positive 60, negative 60 will also cancel each other out. So you will actually end up getting 0 equals 0. And this is of course a true statement. So as you can again see, both our x and y variables canceled out. We got a true statement, 0 equals 0. So this means that these two lines are the same lines or overlapping lines. So when they are overlapping, that means we have a consistent system. We have dependent equations. And of course, this also means we have infinitely many solutions. Okay, so again, you can write your solution set with one of the two original equations, and we can use x plus 2y equals 12, Okay, so this would be, again, if they ask you to write it as a set builder notation, you will write it like this, or if they ask you to choose infinitely many solutions, you can do it that way. Okay, so this was example number 9. So this was to show you how the addition method works with the 3 different types of cases we can have: intersecting at one point, parallel lines, or the 2 lines are the same line. Okay. Just something else to keep in mind is that if you end up solving 2 different systems and they end up getting the same solution set, we can call them as equivalent systems. So just something to kind of keep in mind. Now, the last thing I wanted to talk about was just to see how applications work with these systems of equations. So let's take a look at this first example over here. They're telling us at the Springfield Zoo has different admission prices for adults and children. They're telling us Mr. and Mrs. Weaver went with their 5 children and their bill was $33. Mrs. Wong and her 3 children ended up paying $18.50. So they want to know what's the price of the adult's ticket and what's the price for the child's ticket. Okay, so they're actually giving you what your 2 equations should be here. They're asking us to find the price of the adults tickets and the children's tickets. So you can think of A as being the price of the adult tickets. You can think of C as being the price for the children's tickets. So in the first case, they're telling us Mr. and Mrs. Weaver, so that's 2 adults, and they went with their 5 children, so that's going to be 5 children, and they ended up paying a bill of $33. So that's how you get your first equation. And of course we can do the same thing with Mrs. Wong. So Mrs. Wong is by herself, so that's just 1 adult, and she is with her 3 children, and they're saying they ended up paying a total of $18.50. So that's actually how you would come up with your 2 equations for example 10 over here, and then you can either use substitution or the addition method to solve this. Obviously you don't want to use the graphing method here, so again go with substitution or with addition method to solve this example. Okay, so let's take a look at this guy over here. So I think let's go ahead and use the addition system here, because as you can see we have 2a on our first equation. So if we can make the second equation into a negative 2a, they will cancel each other out. So we'll go ahead and multiply our second equation by negative 2. So remember to multiply each term by negative 2, and that will end up giving us, again keeping the first equation the same, and the second equation will of course end up giving us negative 2a. Negative 2 times positive 3 will give us negative 6c, and then of course 1850 multiplied by negative 2 will end up giving us negative 37. So when we add the 2 equations together, positive 2a, negative 2a will cancel out. Positive 5c, negative 6c will of course give us negative c, and negative 37 and positive 33 will of course end up giving us a negative 4. So if we divide both sides by negative 1, we will end up getting c equals positive 4, which means you are looking at $4 for the children's tickets. Okay, and once you find the amount for the children's tickets, then of course we can put this value back into our original equation, one of the original equations, and see what we get for the adult tickets. So how about we use the second equation? So let's go ahead and find a, and we'll use a plus 3c equals 1850. Now we know c is $4, so that's going to be 4, which will of course give us 12. And then when you subtract 12 on both sides, we will end up getting A equals, and of course 1850 minus 12 will end up giving you 6.5, which will of course be $6.50 for the adult tickets. Okay, so that's how you come up with your answers for this. So, if you think about this in terms of what type of equation we have, this would be the two lines which would intersect at one point. So that's why you're getting a value for C and you're getting a value for A. Okay, so this is how we would go about solving this example 10 over here. Now we have another example over here that they're talking about. A rancher has some normal cows and horses. When they say normal cows and horses, in this example, it basically means all the cows have 4 feet and 4 legs and 1 tail, and same thing with the horses, they will have their 4 legs and 1 tail. So they're saying one day the farmer observed, or the rancher observed, that his animals have 96 legs and 24 tails. So how many animals of each type does he have? So here again we can use C for our cows, H for the horses. So they're telling us that he observed that the animals had a total of 96 legs. Now of course we know that cows have 4 legs. We know horses also have 4 legs, so that will add up to a total of the 96 legs. We know cows have 1 tail, horses have 1 tail, so that would add up to a total of 24 tails. So this is actually how we would come up with our equations for this example over here. Okay, so let's take a look at this guy over here. Now again, you can use substitution or addition to solve this, but you know what? Addition is going to be the most straightforward method over here. So again, we're going to multiply both sides of our equation. Now, in this case, since I have a positive 4c in my second, let's multiply this guy by negative 4 so I can get a negative 4c. So we will multiply the first equation, all the terms, by negative 4, and we will end up getting negative 4c, negative 4h, and of course on the right hand side we'll get negative 96, keeping our second equation the same. Now let's go ahead and add the two equations. So here, negative 4c, positive 4c cancel out, negative 4h, positive 4h cancel out, and then again negative 96, positive 96 will cancel out. So you will notice we'll end up getting 0 equals 0, and of course this happens, we know since this is a true statement, this happens when we have infinitely many solutions, when we have the same lines. Now of course we won't have infinitely many solutions in this case, but obviously the idea is, since we can have cows that have 4 feet and horses that have 4 feet, and each animal has exactly 1 tail, there's really no way for us to distinguish just by this given information how many horses and how many cows we have. So basically we will say this is a dependent system, and there are going to be lots of solutions, so there's no way for us to figure out exactly how many cows and horses this rancher has. Okay, so I believe this was our last example. So again, you should be familiar with most of these solving methods, since this is just a review section. But again, you looked at graphing, substitution, and addition as the 3 different methods of solving your system of linear equations. Alright guys, so look through this. Let me know if you have any questions. Have a wonderful day. Stay safe, and I will see you in class. Bye-bye.